Hi, this is the first video on a unit about kinetics, and in this video we're going to be doing a short introduction to kinetics as well as Beer's law. Kinetics is the study of the rates of a reaction, and reaction goes like this. This side is the concentration, and the bottom side is the time. As time goes on, reactants go from more to less, and products goes from none to more. This is products, this is reactants. And then this gives us our formula of rate is equal to change in concentration over time. And this we're going to talk about more in a different video. And now we're also going to talk about Beer's law. Beer's law has to do with absorption of light. So let's say we have three different tubes here with different concentration and sizes. Here, light goes in, light comes out. Let's call this I0 and I1. I0 is the light going in, and I1 is the amount of light coming out. This is our test tube 1. This has a low concentration, and the test tube is very small. This is our second one. As you can see, the test tube is the same size, but this time the concentration is a lot higher. The amount of light going in is still I0, and the amount of light coming out will be I2 this time. Now finally, this third one, the size is twice as long as that of 1 and 2, but the concentration stays the same as number 2. The amount of light going in remains the same, and the amount of light coming out, let's call it I3 this time. Now, with higher concentration, the light coming out will be less intense. This is because it has more concentration and more particles as well. More particles will absorb more light, causing less light to be able to pass through. Now, if light has a further distance to travel, like in our case between 2 and 3, that means it has a higher probability of hitting a particle. Therefore, more light will be absorbed and less will be able to pass through. So if we take a look at our 1, 2, and 3, and we rank them with light intensity that comes out, which one is going to have the least amount of light coming out? It's going to be I3, because it has the longest distance and the concentration is highest as well. Now our second one will be I2, because although the concentration is the same as I3, it's not as long, and the shorter it is means it has a shorter distance to travel. That means the probability of hitting a particle will be smaller as well, which is why the intensity will be second. And now, which one will be the strongest intensity? That will be I1, because it has the least concentration, least number of particles, and the distance also remains the same. Now finally, we're going to take a look at transmission and absorbance. Transmission is the ratio of light in and light out. And more transmission equal less absorption. Absorbance is how much light is absorbed by a solute. And absorbance is equal to the negative log of transmission. We can write that as A is equal to negative log of T. Now this is our introduction to Beer's law, and we're going to use the absorbance that we learned in this video on the next video where we actually talk about Beer's law. Thank you for watching.